Hello, my mathematics lovers. For a while, we've been talking about fractions. Fractions. We talked about fractions with like denominators, fractions with unlike denominators, how to manipulate them, how to add and subtract and multiply and divide fractions with both like and unlike denominators. So I felt let's step up a little bit higher. Now, this is advanced mathematics. This one is not for the kids. Fractions. What are partial fractions? So we're going to treat the topic of partial fractions today. Now, partial fractions are very useful when you're doing higher mathematics. I know we talked about partial fractions briefly during my undergrad years, but it was when I was doing my PhD research, modeling of environmental variables. We used the logistic equation, and as we were developing the idea, we came across an integral. And to resolve that integral, we couldn't use the simple rules to resolve it. So partial fractions came to the rescue. I became very interested in partial fractions. All right, so without wasting further time, let's go to the partial fractions that we can see. Let's assume you have an integral like this. We're asked to resolve it in partial fractions. How are we going to do this? Out of the integral sign. This is the same expression that was in the integral sign. Now that expression is here. Our goal is to get two simpler fractions that when we combine these two fractions, they will give us the same fraction. And how do we do that? We simply make the terms which make up the denominator of this bigger fraction, we make them the separate denominators of these two fractions that we want to get. Take a look at it. If we had three terms that make up the denominator of the bigger fraction, we're going to have three terms on the right hand side. But in this case, it's a simple one. We just have two terms. So x minus 1 becomes the denominator of the first partial fraction, and x plus 5 becomes the denominator of the second partial fraction. Where did a and b come from? That's the goal. We want to look for the values of a and b. If we're able to get the values of a and b, if we now combine these two fractions together, they will give us this other fraction. And if you take a look very well, these two fractions that we're trying to get out of these bigger fractions, they are fractions with unlike denominators. Did you notice that? This is x minus 1, this is x plus 5. They are unlike denominators. All right, so we have taken this expression out of the integral sign, and then our goal is to break it down into partial fractions. Now we want to look for two simpler fractions that when together, they will give you the same fraction. So this is how to break it down. You bring the first denominator and you put it here, and then the second denominator, you put it here, and then you look for two numbers, a and b. If we're able to find a and b, we'll be able to get two separate fractions. And simplifying this expression, I get this. But wait a minute, you'll be wondering how I got this. Don't worry, I will show you. Let's take it step by step, because my goal is not to confuse you, but to make the explanation as easy as possible. All right, guys, so look at what I did. You have this expression, and then these are the two partial fractions where you want to look for the value of a and b. So I simply multiplied all of the expressions by this denominator. This same denominator, you have it here. So if I multiply this expression by this, of course, these two will go. Do you agree? Yes. So on this left hand side, I get just 6. Now if I multiplied this expression by this, of course x minus 1 will go. X minus 1 will go with x minus 1. Do you agree? So what I have left is a times x plus 5. And if I multiply this expression by this, x plus 5 will go with this x plus 5. Do you agree? Yes. So what I will have left is b times x minus 1. There is a minus. So at this point, there are a number of options open to me. I want to get the value of a and b. So one of the things I can do is to eliminate one of the variables. How do I eliminate one of the variables? Supposing I make x to be equals minus 5, what do you think will happen to this expression? Minus 5 plus 5 is 0. So that would have eliminated a. So let's do that. So 6 equals a into minus 5 plus 5 plus b into, we're assuming x to be minus 5, then a minus 1. And 6 equals, a will go to 0 plus, or b times minus 6. So 6 equals minus 6b. So all I need to do here is to divide both sides by minus 6. So on this left hand side, what will be left is minus 1. Minus 6 will go with minus 6. So we've gotten the value of b to be equals minus 1. And going back to our original equation again, what if I make x to be equals 1? That will eliminate b from this expression. So let's substitute x equals 1 into this same expression. I have 6 equals a into, we say 1 plus 5 plus b into 1 minus 1. So again, 6 equals, what is 1 plus 5? That is 6a plus 0. 1 minus 1 is 0. And since we have 6 equals 6a, all we need to do is divide both sides by 6. So a equals 1, and remember we got b to be equals minus 1. So since we've got the value of a to be 1 and b to be minus 1, this whole expression becomes, a is 1. Instead of plus, we will now have minus because b is minus 1. So we've broken down this fraction into partial fractions. The partial fractions are 1 over x minus 1 minus 1 over x plus 5. It's that simple. But why do we need to go into this? Now wait. Now this was the original question that was given to us. So the reason why we had to go into partial fraction is that this expression simply equals, let me make it clearer here. One all over x minus 1 dx minus integral of 1 all over x plus 5 dx. Now this integral, these two integrals are very, very easy to solve. And how do we solve the two integrals? Well, integral of 1 over x minus 1 is simply natural logarithm of x minus 1 minus, this one is also natural logarithm of x plus 5 and then plus c. And we can tap into a special property of natural logarithms by making this natural logarithm of x minus 1 all over x plus 5 plus c. So we've gotten our answer. Very, very easy. But without partial fractions, we wouldn't have gotten to this stage. So you can see that partial fractions are very, very useful. But guys, I can tell you that, this is about the simplest of partial fractions that you can come across. Yeah, why did I bring the simplest? It's because we are introducing ourselves to these topics gradually, one after the other. We want to enjoy these topics. Mathematics is not easy. It's just some people like to make it very difficult. But I promise you that in the UAE tutorials, we are going to take it one step at a time, make it as easy as possible, explaining so that no matter your level of understanding, you'll be able to flow with us. So this is the idea of partial fractions. Did you enjoy this video? If you did, then please like, comment, and share this video. Please follow my page if you are not yet doing so, and please invite others to follow this page. Also subscribe to my YouTube channel, Ufu Marikaba. Thank you very much. Appreciate you all. Bye.